Now we have discussed about the solar energy storage system. The solar energy is a time dependent or intermittent energy resources. In general, need for wide variety of applications. The problem is especially served for the solar energy when it is used for heating in a winter because of its low availability during this period. So the energy storage may be in the form of sensible heat of solids or liquid medium as a heat of fusion in a chemical system as a chemical energy is product in a reversible chemical reaction. The mechanical energy can be converted into potential energy and stored in elevated fluids. Product of solar process other than the energy may be stored in a tank or utility needed. So the choice of medium for the energy storage depend on the nature of the process. For heating, the energy storage as a sensible heat stored in a water is logical. If air is heated to collector is used, storage is sensible or latent heat effect as storage unit is needed. In such a sensible heat is Papal bed heat exchangers. If photovoltaic or photochemical process are used, storage is in the form of chemical energy or energy stored in the batteries. So such energy may be stored in variety of the needed. That is a heat or electrical or chemical or mechanical or magnetic energy. So the optimum capacity for energy storage system is depend on the some of the factors to be followed. So it should be having time dependence of solar radiation availability, and second is the nature of load expected the process, and third is the degree of reliability need for the process, the cost per kilowatt of stored energy, permissible capacity of permissible capital cost for allocated to storage, and the major thing is the environmental and safety consideration. So that is the energy storage we have classified into mainly having five different categories. One is that thermal storage system and electrical storage and chemical and mechanical storage and electromagnetic storage. So in the thermal storage system further classified into uh, two different types, that is a sensible heat and a latent heat storage. So the latent heat storage is further classified into water storage and a Papal bed storage system. So that is a classification of the thermal storage system. Similarly, there is a electrical storage system. We are classified into three category. That is a capacitor storage, inductor storage, and battery storage system. That is the three classification as stored in the electrical storage system. And third one is a chemical storage system. In that chemical storage system, we have two different classification. One is a chemical storage and a thermochemical storage. That is a two classification we have in the chemical storage system. And similarly, there is a mechanical storage system. In that mechanical storage system, we have classified into three different type of system we are used. One is a pumped hydro storage system and a compressed air storage system and flywheel storage system. So the last one category is that is a electromagnetic storage system. Electromagnetic storage system. So that is a energy storage system. We are classified into five categories: thermal storage and electrical, chemical, mechanical, and electromagnetic storage system. So now we have discussed one by one. For that is a first we have seen that is a thermal storage system. So that is a thermal storage system as energy can be stored by heating or melting or vaporization of material, or energy become available as a heat when the process is reversed. Storage by causing material to rise in temperature is called as a sensible storage system. The storage by the phase change, the translation of solids from solid to liquid, from liquid to vapor in the other mode of thermal storage is known as a latent heat storage. There is no phase changes, just heat is observed means that is a sensible heat, or otherwise there is a material to be changes, that is a change of heat storing medium, that is called as a latent heat storage system. It is possible for both sensible and latent heat storage so occurs the same material when the solid is heated, then melted in the rise of further temperatures. Normally, the thermal storage is essential for both domestic waters and space heating applications. The storage is required in the process of industries agriculture system. So the storage system material depends upon the particular application. For many domestic application such as water or rock storage system have involved. The water and rock are typical example for material which store the energy for specific heat, but there is limited by the comparatively low specific heat. The heat of fusions, that such as a heat of latent heat, which is involved, such as substance changes state from solid to liquid, is provide an attractive method the storing of energy storage, storing of the energy. So first we have discussed on the sensible heat storage system. The sensible heat storage involves a material heat undergoes to no change in phase over the temperature encountered in a stored process. So the some of the basic equation for storage system for thermal storage system, and Q equal to mCp and T1 temperature difference. So that is a heat and mass of mass of air or fluid, mass of fluids and specific heat of the fluids, and the temperature for collectors or difference between the collector's temperature and atmospheric temperatures. That is a normally we have says that is a energy storage, sensible heat storage in the written in the form of this equation Qs equal to mCp in, that is a temperature difference. So that is the basic equation for the sensible heat storage system. And similarly it will be used for the vapors, that is the temperature of temperature ranges such as operated is limited at a lower extreme by the requirement of the process. The upper limit by the process is a vapor pressure of the liquid. The availability of storage thermal energy, so we have used for the in such a volume, it should be used for the in this equation. So Q by V equal to rho Cp and del T, that is a temperature difference, specific heat capacity, and volume and temperatures, that is a heat supplied. So this is the equation for the energy stored by the volume. So that is a rho is a density of the storage medium. So the availability of stored depends upon the product of rho and Cp, such as heat value, but the other material have low values such as water or otherwise rock or gravel or iron shot or iron bed, concrete or refractory material such as magnesium oxide or aluminum oxide to be used. So that is a storage system we have used in a simple diagram we are used. So here we are using as a collector, solar collectors, that here as a storage medium. When the solar radiation or receive the heat is absorbed by the collectors, then passing to storage tank, storage tank. So then it will be taking as heat is stored, then it will be circulated into the recirculated into the air. Suppose we are using as a air means, that is the air is recirculated, or otherwise liquid means that is recirculated here. The heat to be stored when we record the heat during the night time at the times. So that is a load system, that is a heat to be transferred from the here itself, that is entered in a cooled air. For example, if you using for a heating application, air entered into the storage system and then relieved to the or required room space heating system likewise. So this is a basic principle of the sensible heat storage system. And the next one is that is a packed bed storage system, or in that that is we have saves thermal specific sensible heat storage system, that is a two different type of system. One is a water system and second one is a thermal storage packed bed system. So this is the arrangement for the water system. So the most of the common in a water system, most of the common heat transfer fluid, a solar system water, and easiest store the thermal energy by up to that is maximum the optimum tank size is the flat bed collector system, usually about 70 kgs. The following some of the characteristics to be used in a water storage system. So it has a high thermal storage capacity, it should be having high thermal storage system, and inexpensive ready available or material for the storage of heating material. So this is a water storage system we are used for water storage system in a sensible heat methods. So second one is that is a packed bed storage system. So the arrangement as shown to be here, that is a packed bed storage system. So for sensible heat storage with air, the energy transport mechanism, rock or gravel or crushed stone in a bin, crushed stone are used for the heat transfer storage system, that is used for the heat transfer storage system. So it will be filled with the rock materials, or otherwise it is used for uh, um, gravel or crushed stone, likewise it will be used. So its a thermal capacity have as only about half of the water, and bin volume will about, that is a 3 times the volume of water tank. So heat is over same temperature and certain same time interval. So water is superior because of the lower material cost, and lower volume is required per unit of energy stored. So rock does have some of the advantages over a water storage system. If you use it as a rock, some of the advantages: rock is more essentially contained than the water. Rock act as a own heat exchanger, which reduce the total system cost. So the heat transfer coefficient between the air and solid is a high. The cost of material, the cost of the storage material is low. The conductivity of bed and low when the air is not presented. So this is some of the packed bed system is arrangement is shown to be here. We are used as a heat capacity of bed loosely packed particular material through which fluids uh, are fluid usually air is circulated and to more heat from the bed. Normally we are using is a air system. So that is a charging loop and a discharging loop. We are using two different systems we are used. One is a charging loop and a discharging loop. The solar collectors used for the used for collect the solar energy and passing through the bed system, that is a storage tank system. And again we are using to recirculate the air by using of a fan, that is a forced circulation system. We are collecting the air and recirculated to be here. A discharging unit we are used for cold air to be here, passing to be here, and hot air delivered to the space heating methods. Normally that is the operation, the flow is maintained through bed of one direction during the addition of heat, and possible opposite direction due to the removing of heat. So in this system, heat addition and removal from storage cannot be carried out for simultaneously. So the insulation is required for other surface to packed bed or minerals. For the short term storage is a thermal conductivity or otherwise a radial direction is low. So the paper bed exchanger have a good heat transfer condition, that is a good heat transfer characteristics between and air and solids. This type of storage system being used for solar house or otherwise a hot air collector system, that will be used for the packed bed exchanger system. We are used for this system. So now I have discussed on the latent heat storage system. So the latent heat refers to the energy associated with the phase change of material. When the materials undergoes the phase change, the heat is absorbed and released. So the latent heat material stores about, that is 5 to 14 times more heat per unit volume than the sensible storage heat material. So the energy storage, that is can be calculated for energy equal to m into L, where m is the mass of the material that has phase changes and L is the latent heat associated with the phase changes. So this method often failed because the poor thermal conductivity of PCM materials, that is a phase changing materials. So that can be turned into two different phases some of the container. The effective heat transfer cannot be achieved. The phase changing material, they perform a best small container such as the cells, that is a PV cells. Here some of that is latent heat diagrams to be experiment to be shown to be here. So that is a PV cells to be observed to be here, and that is a material to such a collectors to be absorb the solar radiation, and passing through the heat rays reflected to the central receiver towers. So after that, that is a thermal storage system we are using to be here. So that is a material to be heats, that is a fluid material to be heat is transferred to be here itself. So here that is after that heat is transferred by the using of the evaporator or a superheater like as a boiler. Here that is a heat exchangers, that is changes water into or binary solution, that is organic fluids. The organic fluid converted into the vapors and expanded in turbines. Again condenser to be organic fluid, again the vapor is converted into a liquid, that is a pump is recirculated, that is a unit. So here that is a material to be phase changes, that is a, if using as a solid or solid to vapor, that is organic fluid to be used to be here also to be used, that's organic fluid, that is a vapor to liquid to be used for here itself, that is a storage material. So that is called as a latent heat storage system, that's a basic working principle. So the latent heat material, sorry, phase change material must be some of the following categories to some of the categories to be used. So the what are the category means, that is it should be having the high latent heat effects. It contains the high latent heat effect. The it must be having a reversible over a very large number of cycles without any degradation. So it must be, occurs with a limited supercooling. So it's also available contain a material and transfer the heat into out for it, in and out for it. The cost of the material container must be is reasonable. It should, and the phase change must occurs close to its actual melting temperatures. And the phase change must have a high latent heat effect and store the quantity of heat, large quantity of heats. The material should must be available in large quantities, and preparation of phase changing material for use of so relatively simple, that must relatively simple. The material must be harmless, like as a non-toxic or non-inflammable, non-combustible or non-corrosive material should be used. It must be having a harmless. Next one is a small volume changes during the phase change. Last one is that is a material should have a high thermal conductivity both in phase change. High thermal conductivity both in the phase change. So that is some of the parameters, some of the character of the PCA material. If a certain material phase changes, energy storage system can be high capacity. Heat can be, that is a relatively energy should sensible heat by the system when the operated over a small temperature of ranges with sustainable reduction in volume and weight. So that is a latent heat system is nothing but that is a phase energy should be changed from the one phase to another phase. For example, if you are using as a solid fuel, store the system, absorb the solid, and it will be converted into a liquid. Or otherwise, that is a liquid fuel we are using as it may be as a vapor. Likewise, it will be changing the phase for the latent heat system. Now we have discussed on the electrical storage system. So the electrical storage system normally classified into three categories. One is the capacitor and inductors and battery storage system. So first we have discussed on the capacitor storage system. So normally theoretically capacitor should store the large amount of electric energy for the long period. So that is the equation, the total energy have stored in that capacitor for H equal to H capacitor equal to half V epsilon and E2 E square, that is V is the volume of dielectricity and epsilon is the constant and E is the electric field strength. So normally the electric field strength is limited by the breakdown strength, that is for E of dielectric medium. Therefore, the electrical energy stored in a dielectric is limited. So, presently the best dielectric materials available is such as Leica. So, particular in a practical, the conductivity of dielectric is never nil. There will be always be leakage losses. So, present capacitance storage. So, economical time for the no longer than the 12 hours is maximum taking as a 12 hour. To increase the time, much reaches is needed. So, unless the better and cheaper dielectric material for storing the electric energy are found as a capacitance storage system as a large scale will remain uneconomical. So, next one is the inductor storage system. So, the inductor storage system having a low voltage with a high current. So, the H inductors, that is a of V mu Hm squared. That is a mu is a permeability of the material. Hm is the magnetic flux of the density. Normally it's for HM is large, both mu and HM, that is it should be having a permeability with magnetic flux density. So consequently, the high magnetic field or record will convert the large mechanical forces which should be supported by the strong structures. The reverse operation of discharging the store the energy create the another problem, since it will involves opening of the circuit. It's carrying a large current, carrying as a large current. So next one is that is a battery storage system. So the battery is combination of individual cells. A cell is a elemental combination of material or electrolyte, so basic electrochemical energy storage system. So the battery can be thrown the black box into electrical energy, put store the electrochemically. Later it will be re again as electrical energy. The battery storage system may be included under the chemical energy storage also. That is a battery storage also we have says as the chemical energy storage system. So secondary the batteries are uh, interested for the solar electric which are rechargeable, whereas the primary battery on rechargeable. For example, the secondary battery or lead acid or nickel chromium or iron, zinc or sodium sulfurs or sodium chloride. Number of likewise it will be number of number of batteries are used. Generalized cell containing of two electrodes is called as anode and cathode, immersed in a sustained electrolyte. When the electrical loader is connected between the electric charge, separation occurs between that electrode and electrolyte, freezing both the electron and the ion. So the electron flows through the external load and ion through the electrolyte, recombining of other electrolytes. And so electrical energy efficiency of the battery is defined as sum of is called as a watt of hours. Watt hours we are stored in that one things. So one of the found of the electrical, if the either current or voltage is held constant, we must restore the directly as the energy. uh, the cycle life of the battery may be varied greatly depend upon the discharge and a deep discharge, tending to the result of short cycle life. However, cheap discharging may be difficult to avoid the sum of the battery application and electrical vehicles. We are used as a electrical vehicles. That is a three different type of electrical storage. One is a battery and capacity and a induction method. That is a, so battery system is the most suitable method for the electrical storage system compared with other two method. So the mechanical storage system is classified into three categories. One is pumped hydroelectric storage, and second one is a compressed air storage system, and third one is a flywheel storage system. First we have discussed about that pumped electric storage system. So the electric power is excess of intermediate demand is used to pump water from that supply at a lower level to high reservoir level, higher level. When the power demand exceeds the supply, the water is allowed to flow backward through a hydraulic turbine, which drive as a electric powers, which flow down as a turbine, which fired as a electric power. The overall efficiency of pump storage, the percentage of electric energy used to the pump, the water is recovered as electrical energy about a 70%. Pumped electric storage is most economical means that is available to electric utilities. The solar or wind energy in electrical form can be used in this system. There are relatively few sustainable available sites where there is water supply at lower level and reservoir can be constructed at a higher level. But most of this system has been that is a natural or evacuated is a underground is a evacuated system at a lower reservoir. So now being developed should not having that is a greatly increasing a number of possible sites. The method of solar energy stored has advantages of avoiding the intermediate ingredient of solar energy and producing as AC power directly. In this scheme, water act only working fluid. Once the initial volume of water is secured, the only flow needed would be that necessary makeup of for loss of water by evaporation. So therefore, the scheme does not have near the large body of waters. So next one is that is a compressed storage system. So another alternative for the possible storing the energy in a future electric storage system and store the energy in the volume of by the compressed air. A wind turbine, for example, should created would directly pump air into the available pressurized storage tank. Later, when wind is not blowing the energy, so the stored energy air could be utilized to drive the air turbine, whose that is a shaft should be driven by the generators. So applying a need of electric power when the wind is not blowing. So the compressed storage may be applicable to the other solar electric conversion systems. So here that is some of the storage tank that the diagram to be shown. Whenever is not required for that energy that is required, so at the time the supplied of air to be sent into the motor system. So the last one is that flywheel storage system. The flywheel is driven by the electric motor during the peak of the hours, store the mechanical energy. It is has a high speed is increased, and the rotation of flywheel can be used as an operator or generate produce the electric when it required. The same machine serves as a both as a motor when electric is supplied and generated when the armature is rotated by the flywheel. The flywheel could capable by using of electric utility peaking units for the storage of solar energy and wind energy or other vehicle propulsions. The energy recovery efficiency is essential, estimated to be up to 90%. The practically flywheel system such as use are being developed. The basic idea of the flywheel energy storage sometimes refers to the super flywheel or accelerate the sustainable designed physical rotor to a very high speed in a vacuum as electric motors at a state of high energy of stored density or achieved. The energy storage as a kinetic energy, most of which can be electrically regained, which a flywheel run as a generators. So next we have discussed on the electromagnetic storage system. So the electromagnetic storage, energy storage is required use of a superconducting material. So the material such as metal or alloy suddenly lose of essential of all the resistance, the flow of electricity when the cooled below the retain very low temperatures. If maintain the below temperature as a superconducting material can carry a strong electric current with little losses. So the useful superconducting material is available commercially as such as a nibonium titanium at a temperature below it working at a temperature below 263 degrees Celsius. If you go to this compound of nibonium and a tin material, is working as a below 255 degrees Celsius temperatures. An electric magnetic field such as produced by the electric current flowing through a wire or coil can store the energy. Under the ordinary condition, the losses result from the resistance of wire and the energy must be supplied continuously to maintain the current. If the coil or wire were made of a superconducting material and kept the record low temperatures, resistance losses should be very low and once initiated, the electric current would remain constant, almost constant. The electric energy supplied direct current to the wire or coil would be stored in the electric magnetic field. By attaching the coil to a load, to store the energy could be recovered as electrical energy. So this is the base of superconducting magnetic energy storage system under the study of evaluating use of electric utility, load leveling or peak applications. So number of problem are associated with the superconducting storage system. There may be operation and maintenance of cryogenic plant for producing liquid helium is required for very low superior conductive temperatures. So another one is the special structure would be need for withstand the strong magnetic field. So it appears present the superconductivity of storage. At best economical only a large insulation is required. So next one is that is a stratified storage system. It having that is a hot water storage tank, also is called as a hot water tank or thermal storage tank or hot water thermal storage unit, or otherwise says as a heat storage tank or hot water cylinders. So it will be different names we have says. This hot water tank is used for storing hot water for space heating for a domestic purpose. It is essentially the tank should be have essentially insulated for retaining the for certain days. Hot water tank may have built in a gas or oil burner system, so electric immersion heaters or external heat exchangers such as central heating system, or heated the water from other energy sources such as wood burning stoves.